Hello and happy Saturday. In our Unearthed episodes this week, we talked about Antonie Van Leeuwenhoek's microscopes and lenses. It's been a bit since our episode on him came out. That was back on March 12th, 2018. And it's a fun one, I think. So I thought, let's have it as a Saturday classic.
Yep, still features one of my favorite words of all times, animalcules. And after this episode came out, we got several emails about Tracy's recollection of having a book as a child that used barnacle geese as an illustration of the idea of spontaneous generation. And some folks mentioned that this shows up in Susan Cooper's The Dark is Rising series. Others mentioned the 17th century The Herbal or General History of Plants by John Gerard. Neither of these was the book Tracy had as a kid, but we did think we'd mention them just the same.
Yeah, I haven't managed to track down what that book actually was. I also forgot about it in the years that have passed since then. So enjoy, everyone.
Welcome to Stuff You Missed in History Class, a production of iHeartRadio. Hello and welcome to the podcast. I'm Holly Fry.
And I'm Tracy V. Wilson.
And the subject of our show today is fascinating because it's Antonie Van Leeuwenhoek, and he wasn't really a scientist, but he made dozens of important scientific discoveries. He is credited with discovering microscopic life in a variety of forms. And I just want to give a quick heads up to listeners. This episode does discuss reproductive science. So if you listen with younger history buffs and you maybe haven't covered that territory yet, you might want to just give it a quick listen before sharing. But other than that, we're just going to jump right into his life because he did some pretty impressive and also intriguing things.
Yes, and we're going to talk about what we mean by not really a scientist later on. So Antonie Van Leeuwenhoek was born on October 24th, 1632 in Delft, Netherlands. This was a pretty interesting year. A lot of fascinating people were all born that same year, including John Locke, Baruch de Spinoza, Christopher Wren, and Jan Vermeer. All of them born that same year.
Yeah, it was a wild time for important people. And his father, Philips van Leeuwenhoek, was a craftsman. His mother, Margaretha Belvandenburch, who married Philips 10 years before Antonie was born, was from a family of brewers. So they were certainly a respectable family, but they weren't really aristocratic. And according to a book on Leeuwenhoek and his work that was written in 1932 by Clifford Dobell, it was tradition in their family to alternate naming firstborn sons either Philips or Antonie.
While Antonie was the first son, he was their fifth child. He grew up with four older sisters. Philips died when Antonie was only 5 years old, and a few years after losing her first husband, Margaretha remarried. This time it was to a painter, Jacob Jans Molijn. Margaretha and Jacob were married in December 1640, and around this time, the young Antonie started attending school in a village in the Netherlands called Warmond. Later, he was sent to live with his uncle in the South Holland province of Benthuizen.
Jacob died 8 years into his marriage to Margaretha, and Antonie, who was 16 when his stepfather passed away, was then sent to Amsterdam. There, he started learning about textiles, haberdashery, and linen draping through an apprenticeship. And this is likely the point in his life where he first discovered lenses used for magnification. Because in the textile industry, they were used, and sometimes still are, to examine fibers and thread counts up close. But magnification eventually, of course, took on a far greater role in Leeuwenhoek's life.
Several years later, when he was 20, he went back home to his hometown and he set up shop as a haberdasher.
In 1654, Antonie married Barbara de May, a young woman 3 years older than he was, who was the daughter of one of his colleagues in the clothing trade. And that couple had 5 children together, 3 sons and 2 daughters over the course of 12 years. But 4 of those children died quite young. Only one of their daughters, named Maria, who was their second child, lived to adulthood.
In 1660, Leeuwenhoek became the chamberlain to the sheriffs of Delft, securing a regular income for this position. He held the post for 39 years, and he kept receiving income from it after he had retired, all the way up until his death. If you're not clear on what a chamberlain does, here's the description of the job as it was laid out by his employers. Their worships, the burgomasters and magistrates of the town of Delft, has appointed and do hereby charge Antonie Leeuwenhoek to look after the chamber wherein the chief judge, the sheriffs, and the law officers of this town do assemble, to open and shut the foresaid chamber at both ordinary and extraordinary assemblies of the foresaid gentlemen, in such wise as shall be required and needful. Item to show toward these gentlemen all respect, honor, and reverence, and diligently to perform and faithfully to execute all charges which may be laid upon him, and to keep to himself whatever he may overhear in the chamber, to clean the foresaid chamber properly, and to keep it neat and tidy, to lay the fire at such times as it may be required, and at his own convenience, and carefully to preserve for his own profit what coals may remain unconsumed, and see to it that no mischance befall thereby, nor from the light of the candles. And he shall furthermore do all that is required, and that pertaineth to a good and trusty chamberlain.
So it's a lot of words that basically sums up to keep these offices open when we need them, comfortable, warm, and lit, and keep your mouth shut.
And don't burn the place down.
Right. Which I sort of love. I also like that there's a stipulation that he can keep leftover coal at the end of the day. But this stable income that he got from being Chamberlain was significant in that it meant that he could devote his free time to science instead of having to hustle to make ends meet. And specifically to the science of grinding lenses, which was a hobby that Leeuwenhoek had enjoyed for some time, most likely, as we said, piqued by his work in the textile trade. It's also believed that he had, at some point, seen a copy of Robert Hooke's book Micrographia, which featured illustrations and writings about Hooke's work in observational science.
The lenses he was making were specifically microscope lenses, and they weren't like modern compound microscopes. They were very simple, consisting of a single lens, and Leeuwenhoek used them to look at all kinds of things. While he went on to share a great many discoveries, he did not share information about precisely how he was making these observations.
And some of his lenses were incredibly minuscule, less than 2 millimeters in diameter. So tiny, like I would drop it on the floor and never find it again. And of the 500 lenses that he is estimated to have made in his life, several samples, which were given to the Royal Society of England after his death at his request, could magnify anywhere from 50 to 300 times actual size. So they were tiny and mighty. But even though the lenses themselves were examined by other scientists, the manner in which Leeuwenhoek used them to observe things like fleas and bacteria still eluded them. His technique actually remains a matter of some debate.
In a moment, we will talk about the opinion of an observer who visited Leeuwenhoek and offered up what he thought about all these lenses. But first, we will take a moment for a quick word from a sponsor.
As we said before the break, we don't know exactly how Leeuwenhoek made all of his observations, but we're not entirely without insight into how he worked with his lenses. In February of 1685, he was visited by Irish physician Thomas Molyneux, who wrote to the Royal Society about what he saw in Leeuwenhoek's lab. And he wrote this: "As to his microscopes themselves, those which he showed me, in number at least a dozen, were all of one sort, consisting only of one small glass, ground. This I mention because 'tis generally thought his microscopes are blown at a lamp, those I saw I am sure are not, placed between two thin flat plates of brass about 1 inch broad and 1.5 inches long. In these two plates there were two apertures, one before, the other behind the glass, which were larger or smaller, as the glass was more or less convex, or as it magnified. Just opposite to these apertures on one side was placed sometimes a needle, sometimes a slender flat body of glass or opaque matter as the occasion required, upon which, or to its apex, he fixes whatever object he has to look upon. Then, holding it up against the light, by help of 2 small screws, he places it just in the focus of his glass, and then makes his observations."
But apparently Leeuwenhoek did not show him everything. This letter continues, quote, "Such were the microscopes that I saw, and these are they he shows to the curious that come and visit him. But besides these, he told me he had another sort, which no man living had looked through, setting aside himself. These he reserves for his own private observations wholly, and he assured me they performed far beyond any that he had showed me yet, but would not allow me a sight of them, so all I can do is barely to believe, for I can plead no experience in the matter.
So I know we read his little description, but I want to put it in plainer language. And so you get a sense of Leeuwenhoek's known microscope setup in more detail. It sort of resembles a small paddle if you just look at the outline of it. So the main body of this paddle was made up of two identically shaped brass plates, and on each plate there was a small hole about 2/3 of the way up the body. This is the thing that Molyneux describes these holes having apertures so they can be altered in terms of their size. And that lens was placed between the two plates at that point of the hole so you could see through the first hole, through the lens, and then through the hole on the other side. And on the back of the paddle was this pin that was held in place by focusing screws. And so a specimen could be placed on that pin and then adjusted via the focusing screws, so up or down or side to side a little bit, until the object of observation came into focus through the lens.
For the other secret microscope that he showed to no one else, that remains a mystery.
Yeah, and some of his observations were so astonishing in their detail that we know he was using something else. We just don't know what. And even as the haberdasher turned scientist's reputation grew, and he was visited by the likes of Peter the Great of Russia, James II of England, and Frederick II of Prussia, he would not reveal, even to these monarchs, his methods. And that was something of a disappointment in some cases, because visiting dignitaries expected that they would have this curtain pulled back on Leeuwenhoek's secrets, and they always had to leave without such knowledge.
Leeuwenhoek's wife Barbara died in 1666, and 5 years later, in 1671, Leeuwenhoek married again, this time to a woman named Cornelia Swalmius. The two of them remained together for 23 years until she died in 1694.
In 1673, through a connection made by a friend, Leeuwenhoek began corresponding with the Royal Society of England, and from that point on, he corresponded with the group about all of the various things that he saw through his simple microscope. He made a lot of discoveries, but he wasn't entirely methodical about the process. He didn't do formal scientific work.
Yeah, and that's really what we mean when we talk about not a real scientist. He wasn't systematically approaching a field of study. He was just kind of looking at stuff.
Yeah, neat. And then drawing it or having it drawn for himself, usually.
He actually wrote a letter to the Royal Society describing his misgivings about sharing his findings. And in it, he said, quote, "I have ofttimes been besought by diverse gentlemen to set down on paper what I have beheld through my newly invented microscopia. But I have generally declined, first, because I have no style or pen wherewith to express my thoughts properly. Secondly, because I have not been brought up to languages or arts, but only to business. And in the third place, because I do not gladly suffer contradiction or censure from others. This resolve of mine, however, I have now set aside. As I can't draw, I have got them drawn for me, but the proportions have not come out as well as I had hoped to see them. And each figure that I send you herewith was seen and drawn through a different magnifying glass. I beg you, therefore, and those gentlemen to whose notice these may come, please to bear in mind that my observations and thoughts are the outcome of my own unaided impulse and curiosity alone. For besides myself, in our town, there be no philosophers who practice this art. To pray, take not amiss my poor pen, and the liberty I here take in setting down my random notions."
Yeah, he acknowledged, I'm not formally trained in any of this. Please don't send me a lot of critiques.
Also, I can't draw.
Yeah. Which I found really quite lovely, that he was very upfront and said, I don't like being criticized. I don't really know what I'm doing, but I kind of do want to share this stuff.
As another person who can't draw, I empathize.
I'm not very good either. I have a few tricks and then I'm out. But just the same, despite all of these sort of caveats that he gave the Royal Society of England welcomed his findings, and it was through the Society that most of his work became public knowledge. They published many of his discoveries through the years in their periodical Philosophical Transactions. And over the course of Leeuwenhoek's life, 375 different pieces of content attributed to him appeared in Philosophical Transactions. Those first letters and subsequent publications describe, as mentioned in the letter we just read from, there's a later part where he talks about them, bee mouths, bee eyes, and the stingers of bees. He also describes a fungus and a louse.
I love this part because I am very fond of insects' weird mouth parts.
You are a kindred spirit with Antonie Van Leeuwenhoek because he wrote a lot about them.
Yep. So in the mid-1670s, Leeuwenhoek, using his microscopic lenses to look at water, started observing things that he referred to as very little animalcules. It's possibly the most adorable portmanteau of all time. He was looking at protozoa, but the scientists of the 1670s didn't really know what he was seeing. They did not have a concept to match these animalcules. The samples that he used for observation came from everywhere. They came from pond and rainwater, from human saliva, and even from human intestines.
His reputation came under fire for all of this animalcules talk. So when Leeuwenhoek was describing highly magnified specimens of known things like insects and fungus, his work was accepted by the Royal Society and even lauded. But then talking about microscopic living things was another matter entirely. It sounded completely preposterous to a lot of people at the time. It was such a sea change in the scientific world that a number of members of the Royal Society dismissed the work outright. Eventually, the year after publication, and after several people had observed Leeuwenhoek's work, and yet others had managed to duplicate his findings, his discovery was actually recognized.
Next up, we will talk about an area of discovery that Leeuwenhoek was initially reluctant to even consider. But first, we will take another quick sponsor break.
In 1677, Antonie Van Leeuwenhoek began studying spermatozoa from a variety of species. Other scientists had already encouraged him to turn his microscope to the examination of semen, but he had been really pretty apprehensive because he thought writing about such things might be perceived as crude and impolite. Finally, though, Leeuwenhoek found the courage to do some observational work in this area.
When he finally wrote to the Royal Society about what he had seen through his lenses, the letter was awkward and nervous, and it left the matter of what to do with this information up to the recipient. He wrote, quote, "What I investigate is only what, without sinfully defiling myself, remains as a residue after conjugal coitus. And if your lordship should consider that these observations may disgust or scandalize the learned, I earnestly beg your lordship to regard them as private and to publish or destroy them as your lordship thinks fit."
So nervous. So this entire branch of science at the time was loaded with varying ideas and concepts to explain exactly how reproduction played out. There were theories that some sort of vapor was involved in male ejaculate that catalyzed the production of new life on the part of women, and another idea was that all the material to make a new human was contained in the sperm, and that it merely needed to be implanted in a uterus for gestation. And all of these varying theories, there were many others, were categorized into two basic schools of thought. Epigeneticists, who believed that some sort of combining of materials from a man and a woman created life, and preformationists, who thought that the complete makeup of a human was contained in one or the other, the sperm or the egg, and that sexual intercourse served as some sort of catalyst for the process of development.
Leeuwenhoek's work in this area was really controversial. I mean, it should be obvious from what he felt compelled to point out about it in that letter that he wrote. There were some members of the Royal Society who thought he had actually misidentified parasites, and there was a lot of stigma around this kind of research. Once he had started, though, he continued on with it, eventually examining spermatozoa from lots of other animals, mostly mammals, but also birds, fish, mollusks, and amphibians.
Yeah, he did a lot of frog research, but spermatozoa was certainly not the only thing that put Leeuwenhoek on the scientific map. We talked about some of his insect observations earlier, but he noted, for example, parthenogenesis in aphids, and he studied and described, like we mentioned, the tiniest parts of insects and plants, and offered insights that previously had not been known into both of those. In 1680, he made observations that significantly advanced human knowledge of yeast. And his work really led to great strides in the understanding of plant life and how it grows.
He also described red blood cells for the first time known about in human history in 1680, and he was elected a Fellow of the Royal Society of England that year. In 1683, Philosophical Transactions published a drawing by Leeuwenhoek that's believed to be the first graphical depiction of bacteria. He made this discovery while looking at examples of plaque from the mouths of himself and several other people. Quote, "I then most always saw with great wonder that in said matter there were many very little living animalcules, very prettily a-moving."
That's a nice way to describe bacteria.
In your mouth.
Oh, they're so cute. They're just pretty. One of the most important contributions made to science by Leeuwenhoek was the work he did to disprove the concept of spontaneous generation. So just in case you need a refresher on that one, spontaneous generation was a theory that life forms could generate spontaneously from non-living matter. The common example is the once widely believed idea that maggots spontaneously generated from rotting meat.
I had a book as a child that included the example of barnacles that looked like geese becoming geese. And I was at the age of 5, like, are you kidding me?
That's fantastic.
I wish I still had that book somewhere. It was bizarre. So Leeuwenhoek, in his study of little tiny organisms, started examining the life cycles of small creatures. In studying weevils, he observed that they were grubs that hatched from eggs and not, as was commonly accepted, just sprouting forth from wheat.
Similarly, his examination of fleas resulted in a detailed description of their life cycle, including hatching from eggs, which was in opposition to a popular belief that they were generated spontaneously from sand, dust, or other particulate non-living matter.
For a long time, what we now know are ants' pupae were believed to be their eggs. And it was Leeuwenhoek who set the record straight on that, establishing that their eggs are, in fact, much tinier than that, and that the insects pass through a larval stage before the pupa was formed.
His observations were not exclusively focused on tiny creatures, though. He also studied sea creatures, such as mussels and eels, both of which had been at one point believed to be the product of spontaneous generation.
In 1702, he wrote extensively on the microscopic aquatic invertebrates known as rotifers.
So while the subjects of his work were at times quite small, these were really huge developments in the scientific community.
He died where he was born on the 26th of August, 1723.
And we're going to revisit that letter that Thomas Molyneux wrote to the Royal Society while visiting Leeuwenhoek. Because in addition to the sections that we read earlier in the show, he also included this description, which became a little bit famous. I found him a very civil, complacent man, and doubtless of great natural abilities, but contrary to my expectations, quite a stranger to letters, master neither of Latin, French, or English, or any of the modern tongues besides his own, which is a great hindrance to him in his reasonings upon his observations. For being ignorant of all other men's thoughts, he is wholly trusting to his own, which I observe now and then lead him into extravagancies, and suggest very odd accounts of things, nay, sometimes such as are wholly irreconcilable with all truth. You see, sir, how freely I give you my thoughts on him, because you desired it.
But in some ways, it seems as though part of the reason that Antonie Van Leeuwenhoek was so prolific in his observations was because he was an outsider without pre-existing scientific ideas informing his work. He just saw what he saw, and then he recorded it, and he didn't feel constrained by what was expected of a scientist.
Yeah. Even though Leeuwenhoek made his observations beginning in 1673, it wasn't even until the 1800s that people started to comprehend that, for example, the bacteria that he described were linked to disease. So he was so far ahead that science had to have a little time to catch up to what he had discovered. And while his letters to colleagues and to the Royal Society were collected into books, he never formally penned a book or wrote a scientific paper.
In an interview with the Smithsonian in 2016, Marvin Bolt, who was curator of science and technology at the Corning Museum of Glass, which is a fascinating place if you ever get the opportunity to go there, quote, Robert Hooke was looking at parts of animals that were already known. Then Van Leeuwenhoek went deeper to see, on a cellular level, things no one had ever seen before, such as muscle fibers, sperm, and bacteria. He really blazed the trail.
So that's Antonie Van Leeuwenhoek and his teeny tiny science, which I love. I love it so much.
Thanks so much for joining us on this Saturday. Since this episode is out of the archive, if you heard an email address or a Facebook URL or something similar over the course of the show, that could be obsolete now. Our current email address is historypodcast@iHeartRadio.com. Our old How Stuff Works email address no longer works. You can find us all over social media at Missed in History. And you can subscribe to our show on Apple Podcasts, Google Podcasts, the iHeartRadio app, and wherever else you listen to podcasts. Stuff You Missed in History Class is a production of iHeartRadio. For more podcasts from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen to your favorite shows.